Everybody. This is just a little video to go over the last page of the lesson 52 notes with you. This is for people to watch when I am absent and also for anybody who was absent and needs to go back and have a second look. So here on the back page, we're going to be talking about the transformations of the other trig functions, the secant, the cosecant, the tangent, and the cotangent. For the most part, they do follow the same rules as all the transformations we've done for sine and cosine, but of course there are a few little nuances we have to watch out for. Before we do this though, let me just draw your attention back to lesson and homework 48. This was where we saw all 6 trig functions for the first time. So please go back and review these notes if you need to. Remember, of course, these are the ordered pair of the unit circle. If we go around and gather up the y values, that's the sine. If we do the y over the x, that's the tangent, and so on and so forth. We also have this back in lesson and homework 48. We basically took all of those sines, cosines, what have you, from the ordered pairs on the left and put them all here on a table. We then use this table essentially as ordered pairs that we could graph, and that's how we came up with the 6 functions. So here are the sine and the cosecant, and the cosine and the secant. I kind of use color coding here just to remind you which piece goes with which piece. And please note that for all 4 of these graphs, the period is 2 pi, meaning you have to go all the way around 1 full revolution before the repetition starts. That is not the case for cotangent and tangent. Remember, the period of these guys is only pi because of the fact that the tangents are positive in quadrant 1 and 3 and negative in quadrant 2 and 4. They repeat more often, which means only halfway around. So again, that was just to reorient you with the other 4 graphs. Go back and review that as much as is needed. If we go ahead and take a look here at the back of lesson 52, a note about period changes. When you are trying to find what's called the new period, you have to take the old period and divide it by b. So what do I mean by old period? Well, I just reviewed with you that the sine, the cosine, the secant, and the cosecant all have an original period of 2 pi. So that means to find the new period, you'll do what we've been doing, 2 pi over b. For the tangent and the cotangent, because their old period is only halfway around the circle, or pi, to find the new period for any transformations, you do pi over b. So take a look here at the first one. Over on the left side, I am giving you the graph of the secant. Remember, of course, that the secant is equal to 1 over cosine, or essentially 1 over x. Again, if you need to review where the graph came from, go back to lesson 48. Otherwise, take a look here. A couple things that I will remind you of as far as this graph goes. Again, the period is 2 pi. That means that it takes 1 full revolution in order to start repeating, and 1 full revolution is considered to be 1 full up and 1 full down. So again, that takes entirely 2 pi. A note about the domain of this function. Remember, when it comes to the domain, sometimes instead of telling me what x is, you tell me what x isn't. Because of the fact that there's a vertical asymptote here and here and here, one way you could give me the domain is that x cannot equal pi over 2 plus pi n. Remember, that means starting at pi over 2, you can add or subtract pi in either direction, and that will give you all the vertical asymptotes. This is not the only correct answer. Remember, this pi over 2 could be any starting point as long as it's a vertical asymptote. So you could say negative pi over 2 plus pi n. You could say 3 pi over 2 plus pi n. Those would all technically be equivalent. And a note about the range, of course, the y values, negative infinity to negative 1, and then 1 to infinity. Again, all of that was true back in lesson 48, and it's still true now. What we want to talk about is the transformation. So look at my new secant function, secant of pi x plus 3. I need to now go ahead and decide how each of those new values result in the graph that's on the right. So the pi represents a period change. Remember, that's your b value. And then your d value is 3, which means that the entire graph has to move up 3. In order to find the new period, you are going to take the old period, which was 2 pi, divided by b, which is pi, which means your new period is going to be equal to 2. What does that mean graphically speaking? Well, here is now one full cycle of the graph. Here's the up part. Here's the down part. And instead of taking 2 pi to go through one full cycle, it now only takes 2. Notice that from 2 to 4, there's a second cycle, from 4 to 6, so the pattern would keep repeating. In order to find the new domain, you have 2 different options. Option number 1 is to look at the graph and look where the vertical asymptotes are. It appears as though there's a vertical asymptote here at 1/2. It appears as though there's another vertical asymptote here at 3/2, 5/2, and so on and so forth. So if you're able to see them, you would say that the domain is x cannot equal. Pick any vertical asymptote to start. I always like to do the first positive, which is 1/2. Then how far is it to the next one? Well, from 1/2 to 1.5 to 2.5, it's 1n. So x cannot equal 1/2 plus 1n. If you're having a hard time seeing the changes on the graph, here's the other way. You basically take the old domain and you divide by pi. Why would you divide by pi? Again, take the old domain and divide by pi. And you would do that because that is what the b value is. If you want to find the range, again, option 1 is to just look at the graph. You can clearly see that the smallest y value is -infinity to 2. And then it picks up again from 4 to infinity. Again, if you want to know why that is, you can just look at the graph. Or if you look at the old range, you take every value and you move it up 3 because that's the d value. So again, on a test, what would a question like this look like? Well, I would potentially give you this purple equation and I might say, fill in these blanks, or I could give you the graph and ask you to fill in the blanks. So as long as you understand this one, I think you're probably fine. But again, you should know what the secant looks like, what the tangent looks like, what the cosecant looks like, and what the cotangent looks like. So let's do another one. Here in this case, this is the cotangent. Remember, if you were to graph this from scratch, you would go around the circle doing the x's over the y's. Notice that one full cycle is one up-down motion. So that's a cycle, that's a cycle, that's a cycle. And it only takes pi in order for the repetition to occur. So that's the old period. Then let's remember the domain. So the domain, there's a vertical asymptote here, there's a vertical asymptote here. The vertical asymptotes occur at every multiple of pi. So you can say x does not equal. You can either just say pi n, you could say 0 plus pi n or pi plus pi n, basically anything that would encompass all the vertical asymptotes. As far as the range goes, -infinity to infinity, all the positives and all the negatives. We are now given a new graph, and here's the equation for cotangent of 1/2 x. So again, what are the transformations going to be? Well, the 4 out front, that is a vertical stretch of 4. Then the b equaling 1/2, that is another period change. Remember, to find the new period, you're going to do the old period, which was only pi, divided by b, which is 1/2. Multiply by the reciprocal, and the new period is now 2 pi. So again, to show you how that changes, in the original graph, the yellow piece from 0 to pi now exists here from 0 to 2 pi. The orange piece now exists from 2 pi to 4 pi. The green piece now exists from -2 pi to 0. So again, all of that continues. Because of the vertical stretch, because they went all the way up and all the way down, technically they are steeper on the right than they are on the left, although it's a little bit harder to see that. As far as the domain goes, again, you have 2 different options. Option number 1 is you can simply look at the graph and look for the vertical asymptotes. There's a vertical asymptote here at 2 pi, 0, 2 pi, 4 pi. So you can say x cannot equal, and you could say 2 pi n. You could also say 0 plus 2 pi n or 2 pi plus 2 pi n, anything that would make sense. And remember, the other alternative is you can take the old domain and divide by b. So if you divide by 1/2, pi divided by 1/2, that's how you get 2 pi. So again, whichever one of those makes more sense to you. And then finally, the range, you can clearly see that it still goes all the way down and all the way up. So if it's a vertical stretch or shrink, the range does not change. Certainly, it would change if you were moving the graph up or down in some instances, although actually in this case, even if you moved it up and down, it would stay exactly the same. So again, when it comes to the test for secant, cosecant, tangent, and cotangent, you will not be asked to graph anything from scratch. You will only be given a problem like this, where you might have to do some kind of an analysis. And the best way for you to do that is to know what the original parent functions look like. So that is what I suggest you study next.